Okay, so good morning, everyone. Today we will talk about the electric charge, electric field, and electric field line. Okay. So last meeting we have tackled about how to calculate electric field from discrete charge distributions, which means electric field calculations from various distinguishable particles in a system. Now let's move on to continuous charge distributions. Okay. And there are three types of continuous charge distributions: a line charge, which is one-dimensional, a surface charge, which is two-dimensional, and a volume charge, which is three-dimensional. Okay. In line charge distributions, we usually use the lambda to indicate the linear charge density of a material. Okay. And its unit is coulomb per meter. So charge per unit length. Okay. That's why we have this. For surface charge, we denote the surface charge density sigma, which has units charge per meter square or coulomb per meter square. And for volume charge, we have volume charge density rho, indicating with units coulomb per cubic meter. Okay. So we can have various examples. So in one-dimensional could be just one straight line. For surface charge, could be a plane, could be a ring, or disk. And for volume charge, we can be a cube, a sphere, or a cylinder, etc. Okay. So for each of these continuous charge distribution, I think you might have encountered in your math series that when you have continuous charge, we want to take into account a charge, an element or infinitesimal element of our system. Okay. So for line charge density lambda, we indicate the charge, infinitesimal element of charge dq here to be proportional to that line charge density. So the line charge density, lambda, is charge per length or infinitesimal dq per infinitesimal length. Okay. This allows us to discuss about the electric field that an infinitesimal element from the system contributes. Okay. Now for surface charge density, we consider now a charge element dq again, but it has infinitesimal area dA, so that we can talk about the electric field that it contributes, or the electric field due to this small part of this continuous system. Okay, so our sigma charge density is just charge per area, or dq over dA. And for volume, we have another charge element dq proportional to the volume charge density, which is charge per volume. Okay. So in calculating continuous charge, so we consider the system S, the whole system S, and then we consider each infinitesimal charge, each infinitesimal charges inside the system. For example, dq1. So this dq1 will have a distance r1 from a point P. Okay. So if this S is our source and this point P is our point of interest where we want to calculate the electric field due to the source, right? So we have this dq1, an infinitesimal charge with a distance r1. That will be your r1 hat, the r hat direction. And so this will contribute a electric field at point P, dE1. Now consider another infinitesimal charge, dq2. Again, this will have a different distance. This might have a different distance from the point P and a different unit vector, right? And this will contribute another vector electric field, infinitesimal electric field. We do this for each of the infinitesimal parts of the system or of the source. Okay. So for a continuous charge distribution, the total electric field due to this source is just the sum of all the infinitesimal electric fields from each infinitesimal charges in our source, given by this summation, right? And since it's continuous charge, we cannot distinguish each dq1 from dq2 from dq3, etc. Then this summation becomes an integral. Okay, so an integral k over the whole surface dq over r squared r hat. So yung summation natin for discrete charge, magiging integral lang. Pero same pa rin halos yung form. Okay. So tips in problem solving. In solving problems involving continuous charges, so pick an infinitesimal charge element dq. Then draw the electric field due to the chosen dq. This will have a magnitude similar equal to this k dq over r squared. Okay, where dq can be lambda dl, sigma dA, or rho dV depending on the system, if it's a line charge, surface, or volume charge. The r will be the distance between the point, the source, the field point, and the source dq. Then decompose dE into its components, if any, and then integrate all over the object to solve for the total vector field E. Okay. Let's provide an example. Suppose we have a charge rod, a positive charge plus Q, uniformly distributed on a rod of length L. What is the electric field along this rod? A distance D from the right end of the segment. So we have this rod initialized at located at x equals 0 to x equals L. So it has a length L and it has charge plus Q. And we want to find the electric field at point P, a distance D from L. Okay. So we pick an infinitesimal section of rod distance x from the origin. So it should be something like this. This will be the infinitesimal length dx from our rod. Okay. And then we write down, this will have a distance x from the origin. Okay. So just some dummy variable, random variable x. So this infinitesimal charge dq will have a length dx. And we treat it as a discrete one. So parang we shift from continuous to discrete and then go back to continuous. So treat this as an infinitesimal section as a point source. And then we calculate our electric field due to this dq. Okay. And that will be the direction. Okay. Since positive charge to, kung ako ay nasa point P, ako ay ma-repel. Okay. So that's why, kung ako ay nasa point P, yung electric field will be to the right. Okay. So this now is your infinitesimal dq. Okay. Since the rod has a uniform charge density, lambda, then lambda is just your charge per unit length, or in infinitesimal form, which is your infinitesimal charge per infinitesimal length. Okay. So dq is just, we just rearrange this, lambda equals dq over dx into this, dq equals lambda dx, where lambda again is q over L. Now the separation r between point P and dq, so what will be our separation distance? Is just, so if this is distance d, and this is distance L, and this is distance x, so we just have L plus d minus x, right? So this is x, so this distance will be L minus x, okay? Why can't I draw? Okay. So this is x. So this distance will be x. No, sorry. This will be L minus x. Okay. And this is your total distance r. So R equals L minus X plus D. Okay. So or L plus D minus X. Okay. So DE, our infinitesimal electric field, can be written as K dq over R squared, where dq is lambda dx, right? From here. Okay, dq is lambda dx. And R is just L plus D minus X. Ano yung direction? R hat becomes I hat. So vector form na to dapat. So this should be vector form. So dE vector is K lambda dx over L plus D minus X squared I hat. Okay? And then we integrate this vector all over across all charges for the whole length. So from 0 to L, from x equals 0 to x equals L. So E equals K lambda. Okay. So lambda is constant. Bakit siya constant? Kasi nga uniform charge density. So uniform, so lalabas lang yan. Okay. We plug in the boundaries 0 to L. Let U equals L plus D minus X. Right? So if you let U equals this one, yung sa ilalim, so yung integral natin, magiging K lambda integral ng du, actually negative du over u squared. Okay. Kasi u equals L plus D minus X. So du equals negative dx. Kasi negative to. So yung dx, papalitan natin ng negative du. Kaya ito yon. Tapos yung nasa baba, magiging u squared or u to the minus 2. And then, if you integrate u to the minus 2, so meron ka lang u to the minus 2 du. Right? Tapos may k lambda ka pa dito. So, k lambda. So, u to the minus 2, integral niyan is just u minus 2 plus 1 over minus 2 plus 1. Right? Times yung k lambda. Okay? Ay, may negative ka pa pala sa labas. Ito pa. So, may negative k lambda ka. So, negative 1. So, magiging positive lang to. Magka-cancel. Negative. So, may titira ka lang ng k lambda. U. No. K lambda over U. Okay? Evaluated from if x equals 0, yung nasa baba kanina, then U equals L plus D. Okay. If x equals L, then we have L minus L0, D lang yung lalabas sa taas. Okay. Kaya, K lambda over U evaluated from D to L plus D. So, meron ka ng K lambda, 1 over D, ito yung minus 1 over D plus L I have. And that's why we get this. Okay? Okay? So this will be the total electric field at point P, a distance D from the rod. What happens when this distance D is very large or D is very greater than L? So kapag nasa malayo, pag kinakalculate na natin electric field, malayo dun sa line charge density na yon. Actually, finite line charge na yon, mukhang magiging point charge. Kasi nga, sobrang layo natin. So, sipin mo mayroon kang rod na nasa moon. Gusto mong kunin yung line charge, ay yung electric field due to that rod. Since sobrang layo, halos di natin nakikita, mukha na lang siyang point charge. So, if we take this, so d, 1 over d, goes to 0. No, not yet. Combine itong nasa loob. So, meron kang d plus l minus d sa taas over d times d plus l. So, magiging l na lang yung nasa taas, right? Over d plus l. But d is very greater than d plus l. So that the denominator will absorb, itong factor na to sa denominator will just approach d. Negligible na si l kasi nga sobrang laki ni d, yung distance d. And so, since d na lang yan, magkakaroon ka lang ng l over d squared. Since q ay yung lambda natin, yung charge density is uniform, which is just q over l, we apply that and we plug in for lambda, we retrieve the electric field formula for a point charge. Okay. And this is actually true for any charge distribution. Kahit ano pa yung shape ng charge distribution mo, right? Kung nagme-measure ka ng electric field very far from that distribution, magiging mukhang point charge lang siya. Yun yung main point natin dito. Yun yung tatandaan nyo. Okay? Kahit ano pa yung charge distribution, if you measure the electric field or calculate the electric field due to that system, due to that source, very far away from that source, point charge, ang itsura na may makuha mo ng electric field is mukhang point charge. Okay? Now let's consider a field of a charge rod, a vertical charge rod. Okay? So kanina naka-horizontal yung charge rod. So ngayon let's consider vertical and a point P away from the rod, from the bisector. Okay? So i-orient natin yung charge rod in the y-axis from negative A to A. Find the electric field at point P at distance x from the bisector of the vertical rod. Okay. So again, follow the tips. Pick a charge element dq. This time, meron siyang length dy. Kanina length dx kasi nasa x-axis. Ngayon, nasa y-axis siya, so length dy naman. Then, we calculate or we find the direction of the electric field at point P due to this dq. So, pababa siya or southeast. Okay. So, this DE, this infinitesimal electric field, will have magnitude k dq over r squared, where r is yung distance from dq dun sa source, dun sa to point P. Okay. Since the rod has uniform charge, again, lambda, this time, lambda is charge per length. So charge is total charge is q over total length is 2a. Okay, a dito, a din sa baba, so 2a. And that will be equal to the infinitesimal form dq over dy. Okay. And we have obtained these simplifications. Okay. The separation distance between the point P and the source dq will be square root of x squared plus y squared. Right? Pythagorean theorem. Okay. So now, plugging everything here, plug natin itong lambda dy dito sa dq, plug natin yung r dun sa de. Okay, so de can be written as the following. K lambda dy over square root of x squared plus y squared squared. So wala na yung square root. Okay, meron ka na lang ganito. Then we decompose into its x and y components. Okay, so dx, the x component of this electric field, infinitesimal field, is this, yung magnitude times cosine alpha, where alpha is this angle. Okay. And then dy is sine alpha naman. Okay. So vector decomposition. And then express each cosine alpha and sine alpha in terms of x and y. So madali lang yan. So since alpha to, okay, Since alpha to, wala na, wala. Ayan. So, alpha din dapat ito. Okay? So, pwede tayo magsokatowa in this triangle. Kasi ito yung alam natin yung dimensions. So, cosine alpha is adjacent x over hypotenuse r. Yun yung x over r. Magiging ganyan. And for sine alpha, that will be opposite naman. So, opposite naman ng alpha is y. So, over the hypotenuse r, which is just square root of x squared plus y squared. Okay. And then, now we substitute yung values. So, for dx, ito yung cosine alpha, x over x squared plus y squared. We combine yung x squared plus y squared sa baba na square root sa kaya to. So, magiging 1 plus 1 half yung exponent. So, magiging 3 halves. Same with dey. Okay. And then, now we integrate. For ex and ey. Sa x component, we use trigonometric integrals. Okay. Let x, let y, x equals x tangent alpha. So that dy is x secant squared alpha d alpha. Okay. So let y, ito, x tangent alpha. So this is a new angle alpha. So yung derivative naman ng dy is x plus derivative ng tangent alpha, which is just secant squared alpha. Plug in into our integral, we get this. Okay. So yung x ay x tangent alpha. So ito yon. And then sa baba, meron kang okay. So parang gumawa ka ng new triangle. Ito yung alpha. Ay, hindi. Okay na yan. Joke lang. Iba na pala yan. Okay. Ayan, so x is x tangent alpha. Yung dy, x secant squared. Ito, so meron kang x squared secant squared dyan. Yung sa baba, we plug in yung trig identity again. So yung x squared plus y squared. From here, right? So from here, we square that. So meron akong y squared equals x squared tangent squared alpha. So yung y squared, ito yon x squared tangent squared alpha. So ipapasok ko siya dito. Tapos ito ay x squared lang. Okay. So meron kang x squared plus x squared tangent squared alpha. Lalabas yung x squared kaya mapupunta siya dito. Pero naka-raise siya sa 3 halves. So x squared raised to 3 halves. So x cube may iwan dito. Sa loob, meron ka na lang 1 plus tangent squared alpha. Okay. And so, we integrate this. We simplify. Magiging cosine alpha na lang sila sa dulo. So, integral ng cosine is just sine. Okay. Evaluated at these endpoints, we plug in those, and we find that the x component is equal to this. For the y component, medyo mas madugo siya ng konti, pero we can use symmetry arguments. Okay? So we let u yung nasa baba, tapos meron ka na lang du is 2y dy. Okay, so maging 2y dy. Yung nasa taas. Then if we simplify yung u, etc., magkakaroon ka ng integral na if you evaluate from the endpoints, magiging 0 siya. Okay. So, assignment nyo yan. So, assignment nyo na lang. Paano magiging 0 using itong let u equals x squared plus y squared. Using symmetry arguments, mas madali. Bakit? Kasi if we choose a dq here, right? We choose a dq here, ito yung dq1, meron siyang de1 dito. Okay? Now, if we choose another dq on the opposite side, meron naman siyang dq2 pataas. De2 pataas. Okay? And we can see na if we decompose yung y components, kunin natin yung y components, ito yung de1y, y yan. Ito naman yung de2, okay, y. And same lang sila ng magnitude kasi uniform yung charge, so parehas lang yung charge ni dq1 kay dq2. Pero opposite lang sila ng direction. So they will cancel each other out. And that is true for any other dq infinitesimal sources. Okay? So from symmetry, since symmetric yung nasa taas, dun sa nasa baba, then magsi-zero lang dapat yung y component. Okay? So, for the final electric field, so EXI hat plus EYJ hat, but EY is 0 due to symmetry. We just have this. The total electric field is just along x-axis. Now we have some special cases. So if x is very greater than a, yung nandito, yung nasa denominator, magiging negligible ngayon yung a. Sabihin again, if our point P, if we measure our electric field very far away from the source, right, magiging negligible yung length ng rod. So that is x is greater than a. So ito, magiging square root na lang ng x squared or of just x. Again, the finite line charge becomes a point charge. So magiging x na lang yon, and we recover again the electric field of a point charge. Okay. So ganun lagi if we are very far away from the source. Now, kung malapit naman, if x is very small, smaller than a, so pag sobrang lapit naman natin sa charge distribution, yung denominator, magiging square root na lang ng a squared. So magiging almost 0 to, approaching 0 yung x squared. So square root ng a squared is just a. And we obtain this. Okay. So a na lang yung nasa baba. Yung q, papalitan natin ng lambda form niya. Okay. Which is just a lambda or 2a lambda. So L times lambda yan. So yan. We just obtain that. Magka-cancel yung a. So we just have 2 lambda over x. So pag malapit naman tayo, sobrang lapit natin dun sa line charge na yon na vertical, yung finite line charge magiging parang infinite. Which makes sense kasi kung halimbawa meron kang ruler, di ba? Tapos meron kang langgam. Kung ikaw yung langgam, tapos you're just viewing the ruler at some distance, nakikita mo yung buong ruler. Pero pag lumapit ka dun sa ruler ng sobrang lapit, hindi mo na halos nakikita yung buong ruler. So isipin mo mukha na siyang infinite line. Okay? So very far away, mukhang point charge. Very near, mukha namang infinite line charge. And this is the electric field due to an infinite line charge. Okay? In general, yung I hat, pwede natin gawing R hat, which is just a source to point unit vector. And for this, maraming, there are 2 possible cases. If yung charge density is positive, at point P, ito yung magnitude, so naka-absolute value. Yung direction, outwards. Okay. So again, this is due to an infinite line charge. So kung positive yung line charge natin, yung infinite line charge, outwards yung electric field. Pero same yung magnitude on either side. Okay, 2k lambda x. Kapag negative naman, same pa rin yung magnitude, but now the directions are inwards. Okay. Now let's consider a ring charge with a uniformly distributed charge dq around a conducting ring of radius a. Find the electric field at point P on the axis of the ring at a distance x from its center. Okay. So again, we pick a charge element dq. Now this will have a length, imbis na dx or dy, meron siyang arc length ds. And meron siyang corresponding electric field at point P given by that magnitude and this direction. Since the ring has a uniform charge, so magiging mukha lang siyang line charge na pinaikot, so it's just charge per length, Q over the total length, which is 2 pi A. Okay? In infinitesimal form, dq over ds lang siya. And the separation distance is just x squared plus a squared. Okay? Malito. X squared plus a squared dapat. Tama to. Tama to na dito. So, x is yung distance from point P to the center. Tapos yung a is yung distance ng center to the dq. So, plugging into our infinitesimal electric field, we have the following. Then, we decompose to its x and y components. So, again, meron tayong cosine alpha and sine alpha. And we can use the same triangles kanina. Okay? So, here, y is equal to a naman to. So, y is equal to a dapat. Kasi yun yung radius. So, dapat y equals a to. Kasi ito yung y, yung radius. Okay? Ganon din sa baba. So, ganon din sa baba. A din yan. And then, we substitute our values and simplify. And then, we integrate. So, I think medyo advanced yata yung integration na to. So, unless nadaanan nyo to sa Math 22 or Math 23. But let's check. If nadaanan nyo na or if hindi nyo pa nadaanan, maybe you can solve it again later on. Okay. But now, I'll just show you how to solve this. So, in the x component, so labas natin yung mga constants. So, we are integrating actually on ds lang. Right? So, lahat actually ng variables na nandito ay constant from that with respect to this integration. So, yung x at y, pwede nating ilabas. Kasi nga ds lang yung integration natin. So, ilabas natin yan. Integral ng ds is just s, evaluated from 2 pi a to 0 is just 2 pi a. Kaya magka-cancel lang itong constant. And we are left with that. Again, for y, we can use the symmetry argument. So, by symmetry, again, magka-cancel lang yung mga y component from here. So, ito yung, ano ba yan? Okay. So, yung y component nito is just this. Right? On the other side, meron ka ring dq doon. Magka-cancel lang yung y component nila. Okay. Kasi same magnitude, different opposite directions. So, the net electric field is just in I hat direction. If we again look at very far from the ring charge, so x is greater than a, so etong denominator magiging x cubed na lang, x squared, ito ay a squared approaches 0. So, magiging x squared raised to 3 halves, which is x cubed. Meron kang x sa taas. So, magkakaroon ka na ng x over x cubed, which is just x squared sa baba. So, mukha na naman siyang point charge. So, kapag very far ka from that ring charge. Okay. And for the discharge, so I will leave this to you as an reading assignment. So, similar lang yan. Although, this time, yung ipipick mo lang na charge element is a ring. Okay? Kasi, alam na natin yung itsura ng electric field ng ring charge from our example before. And then, we just evaluate this ring for different R. So, parang ang gagawin mo lang, ang DQ na pipiliin mo is just a ring kasi nga alam na natin yung DE niya, alam na yung electric field contribution ng isang ring. And then we just integrate from with the radius 0 to radius 8. Kasi solid na to. Okay. So, ganun lang yung mangyayaring integration natin dito. And we obtain this. Okay. Kung very large yung disk, so R approaches infinity, if infinite to, then meron kang 1 over something very large, that means medyo magiging 0 to, we are left with just sigma over 2 E naught. So again, sigma na yung ginamit kasi surface charge na to. Okay. And this sigma over 2 E naught I hat is an electric field due to an infinite plane charge, which makes sense kasi nga kung malaki yung R, kung malaki yung radius, it approaches infinity, then mukhang infinite plane na yung nakikita natin. Okay. In general, the electric field of an infinite plane charge is sigma over 2 E naught. R hat yung source to point unit vector. Okay. And there are again two cases. Kung kanina sa infinite line, pwede maging positive lambda or negative lambda. Ganun din naman sa case ng plane. Pwede maging positive sigma or negative sigma. But, same lang yung makukuha natin. Except for the magnitude, of course. So, magnitude, sigma over 2 E naught, pero in direction outwards from the source. Kung positive yung sigma. Kung negative yung sigma, inwards lang yung magiging direction. And makita nyo, uniform electric field lines. Okay. So, perpendicular yung field lines dun sa plane. Okay. So, let's see another example. What if dalawang infinite plane charge? So, two infinite sheets of charge with surface charge density plus sigma and negative sigma are placed parallel to each other at a separation distance d. Find the electric field above, below, and between the sheets. Okay. So, paano to? So, let's consider sheet 1 yung nasa baba, and plane 2 yung nasa taas. Yung sheet 1 yung positive sigma and yung negative sigma yung nasa taas. We can draw the vectors or the electric field contribution as follows. So, from E1, from this sheet 1, I'll use screen. On the sheet 1, ano yung bang, ayun. From the sheet 1, ay mali. Hindi pa pwedeng maging. Okay, never mind. Or baka pwede to. Ayun, meron pala nito. So, from sheet 1, itong sheet na to, okay, positive sigma, so dapat outwards yung direction ng electric field. So, ito yung effect niya, outwards, outwards, and then outwards. Okay? Si plane 2, negative sigma naman siya. So, dapat inwards naman yung direction ng electric field sa kanya. Okay? So, let's consider another color. So, from here, ito yung plane 2. So, inwards, inwards, inwards. And since parehas sila na sigma yung magnitude ng charge density, then parehas lang dapat din yung magnitude ng electric fields nila. Given by this. Okay? Ay, sorry. Okay, so yan na yun. And then we just add up for each region. So above, E1 plus E2, parehas lang yung magnitude but different direction, plus j hat and minus j hat. So we get 0. Between, mag-add up naman sila kasi parehas ng direction. And below, magka-cancel ulit. Okay. So, ang electric field due to two infinite planes of charge na opposite signs, right? Meron lang electric field ay nasa gitna. Wala kang electric field above or below. Okay. So another example, an infinite line of charge with linear charge density plus lambda was placed a distance d on top of an infinite sheet with surface charge density plus sigma as shown. So what is the net electric field at point P at a distance of 2d from the line? Okay. So meron kang infinite plane sa baba, sigma, mas may infinite line ka na lambda. Tapos, ito yung distance, d and 2d. So ano ngayon yung electric field at point B, a distance 2d from the line? Okay? So actually, kapag meron ka na magkaibang sources, maraming sources of charges or electric fields, mag-a-add up lang sila. Okay? Superposition lang tayo. Kung nagsusuperpose yung forces, yung electric force, magsusuperpose din yung electric field. So, yung electric field at point P is just yung electric field due to the line or due to the sigma, the surface charge, and due to the line charge lambda. Alam na natin yung equations ay yung formulas nila. Just the following. Plug in our values and we get this. Okay. So kung marami kang different charge distribution, i-adapt mo lang lahat ng sources. Okay? Lahat ng contribution. So another example, 2-point charges and a point P lie at the vertices of an equilateral triangle as shown. Both point charges have the same magnitude Q, but opposite signs. So negative Q si charge 1 and positive Q si charge 2. Okay. What is the net electric field at point P? So ano yung net electric field at point P? Ano yung direction? So, yung electric field point towards the negative charges. Again, bakit? Kung source mo ay negative charge, yung electric field lines will be drawn towards that negative charge. Right? So, electric field here, hindi ko na pala kailangan i-drawing. It's just that. And for charge 2, since positive, magiging palayo. Okay? Kasi, ang electric field due to a positive charge is radiated outward. So, if you add them, ang net force ay upwards, which is in the positive y direction. Kung parehas naman silang negative, okay, so again, E1, same pa rin, drawn towards charge 1. Pero yung E2 mo ngayon, ganun din, drawn towards charge 2. So if you add them up, ang net force mo will be in the positive x direction. So paano naman kung semicircle? So meron ka ngayon positively charged, uniformly distributed around semicircle. So ano ngayon yung magiging electric field that this charge produces at the center of the curvature? So actually, hindi naman natin kailangan masyado mag-integrate, pero papakita ko na lang din paano integrate yun. But then, kasi direction lang naman yung tinatanong. Like, ano yung direction? So, try na lang natin integrate. So, pick a charge element with arc length ds. The electric field at that point due to dq is given by the following. Okay. Since the semicircle has uniform charge, we apply this q over L, where L is pi a. Okay. And we find the separation distance to be just r. Or the a pala, yung radius lang. We decompose yung components, x and y, and we integrate over the circle. So actually, since yung x and y components natin is just d theta, right? So madali lang kasi integral lang ng cosine, sine, integral ng sine, negative cosine. And then we plug in yung mga tawag dito, bounds ng integration, and we evaluate into this value. So ang net direction is negative j hat or pababa, negative y direction. Okay? So madali lang i-integrate, kaya-kaya niya integrate. Okay. So please try integrating this. Kaya-kaya niya integrate. Okay? Now let's talk about this electric field line. So nagdi-discuss tayo ng electric field. Tapos nagdodrawing tayo ng mga lines. Ano ba 'tong electric field lines talaga na to? These are imaginary lines or curves drawn through a region of space. And it's always tangent at any point in the direction of the electric field vector at that point. Okay? So hindi siya trajectory exactly, pero siya yung nagsasabi kung saan pupunta yung charge kapag naglagay ka ng charge malapit dun sa source ng electric field na yon. Okay? And more importantly, electric field lines never intersect. At any particular point, the electric field will have a unique direction, as shown here. So at point P, ang direction niya is pataas. At point R, ganito naman yung direction niya. Okay? So mukha siyang trajectory, pero hindi siya exactly trajectory. Okay? Ang electric field line, siya yung nagsasabi na kapag naglagay ako ng point charge dito sa point P, pag ganun yung magiging direction niya. Pag ganun yung magiging velocity or motion. Okay? Pag nilagay ko naman siya sa point R, pag ganyan naman yung magiging direction. Okay? So what is the electric field of a point charge? So again, kung point charge, radiating outwards yung electric field lines. So positive charges acts like a source for electric field lines. Okay. While negative charges acts like sink of field lines. Kasi nga, papasok sa kanya yung electric field. So, if we draw the electric field lines of 2-point charges of opposite sign, so ano mangyayari? Magre-radiate outwards kay positive, pero mag-sink kay negative. So, it will be something like this. Okay? So makita nyo, nagka-curve yung iba due to the presence of another source. Kung parehas naman sila ng sign, both positive or both negative, magiging ganyan naman itsura. Kung negative yan, babaliktad lang yung arrows. Okay? So again, nakikita natin may curving up because of the presence of another source. Some notes, so these are the electric field lines. The denser the electric field lines, the stronger the electric field. Okay? So ibig sabihin, at this point, mas mataas yung E as compared dito sa malayo. Okay? Kasi dito, mas dense sila, so mas dikit-dikit yung electric field lines. So pag ganun, alam natin na stronger yung field doon. Dito, mas malalayo, mas spaced out yung field lines, so it will have a weaker electric field. So the strength of the electric field is proportional to the density of the field lines. So some rules in drawing field lines. No field lines, again, should intersect. So mali yan, hindi yan pwede. Kaya sila nagka-curve away from each other. Okay. A field line must begin from a positive source and end to a negative source. Okay, so laging ganun. The number of field lines arising or emerging is proportional to the magnitude of charge. So for example, kung D plus Q, so magnitude niya ay 1, right? Or, yeah. Nag-draw ka ng 4 field lines emerging from that. Kapag nag-draw ka naman ng field lines from charge 2Q, dapat twice as many. So kung 4 yung field lines mo kanina, dapat maging 8 field lines. So twice as many. So kung 3Q, 3 times as many. Okay. Kung negative naman, twice as many pa rin, pero baliktad lang yung arrows. Okay. And at a region very far away from system of charges, the system must look like a single charge particle, which is yung nakita na natin from before. Right? Every time mag-solve tayo ng any charge distribution, kapag sobrang layo natin dun sa source, mukha lang siyang point charge. Example. So which of the following is possible set of electric field lines? Okay. So si A, hindi na pwede. Bakit? Kasi meron ka something sa gitna na nag-act as both a source and a sink. So it is not possible. Yung C, hindi rin pwede kasi meron kang mga field lines na that started somewhere na hindi mo alam kung saan. Okay? Yung B, pwede. Possible set siya ng electric field lines. Right? Kasi meron kang source, alam mo na may source ka sa left, meron kang source sa right, tapos hindi sila nag-intersect. Yung D, hindi siya pwede, impossible, kasi hindi mo alam kung nasaan yung source at nasaan yung sink. Okay? So, ang sagot lang dito ay B. Okay? Another example. So, given charges plus Q and minus 2Q, which of the following diagrams show a correct representation of field lines? So, automatic, letter E, hindi na pwede kasi may nag-i-intersect. So, wala na yan. Si B, hindi na rin pwede by elimination kasi yung charge na to nag-act as a source and a sink. So, bawal din si B. Okay? So, ang possible na lang ay si A, D, C, or D. So, bilangin na natin yung field lines. So, kung plus Q, so kung halimbawa si A, plus Q yung nandito, meron siyang 4 field lines. So, na-expect natin kay 2Q, meron dapat siyang 8 field lines connected. So, bilangin natin kung 1, 2, 3, 4 to, sa 2Q, meron kang 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, mas marami. So, dapat 8 lang yung na-expect natin. So, mali na si A. Si C naman, actually, mali na rin to. Kasi, meron kang tama yung number of lines, number of field lines, 4 dito, tas 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, 10 din pala. So, mali din pala ito. Kasi 10 yung dun sa kabila. So, dapat 4:8 yung ratio. So, tama lang dito ay si D. So, bilangan natin, 1, 2, 3, 4. Sa kabilang charge, meron akong 1, 2, 3, 4, 5, 6, 7, 8. Tama ba yung direction? Yes. Kasi kung plus Q, positive, outwards. Kung negative 2Q, inwards naman. Okay. So, ang sagot dyan, D lang. Okay. So, another example. The following illustration shows electric field lines due to 3-point charges. Where is the strongest electric field? Kung saan closest together, kung saan farthest apart, kung saan may field lines parallel, or none of the above. So, dapat where the field lines are closest together. Kasi nga, strongest yung electric field, the more dense yung field lines. So, saan itong mga points na ito? Okay. So, saan yung mga points na ito? So, dito, dense yung field dyan. So, stronger dyan. Dito, dense din dito. At dito rin. Okay. So, nandyan yung mga denser or strongest electric field. Sa kabila, dito sa mga nandito, weak na yung electric field. So, weak na yan, weak na dito, weak din. Okay. Okay, so yun lang muna for today. We will continue on Thursday dun sa dipole and dipole moment and electric flux. So please review, or kung gusto niyo magbasa ng ahead, you may study ahead. So actually gusto ko sanang i-discuss to in person, like sa board talaga, kasi nga yung mga integration and etc. But circumstances didn't allow that to happen. So sana ma-appreciate nyo pa rin yung discussion natin today. So please be safe, and I'll see you on Thursday. Thank you, everyone.